and explain using 2-digit divisors and 4-digit dividends. And I know that you've been exploring that for a little bit, division. Actually, you've been doing it for a few years. If we think back to 3rd grade, to 4th grade, now to 5th grade. And I have a problem that I've used, and I'm hoping you guys can help me out with that. All right? So if you will take one and pass one down, and take one and pass one down. And he's got his. Take one and pass one down. All right. All right, so I've got a problem here. Marcia has 480 stamps in her stamp collection. She wants to split them evenly in the boxes of 32. How many boxes of stamps will she have? Take a second, read through the problem. On your own, go ahead and try to solve this problem. Go ahead. As you finish up, go ahead and compare your answers with those sitting around you, with your groups. Find some similarities, differences.
I did 32 times 1. Yeah. And then I brought down.
Keep going, keep going. You're doing good.
And then I
So you'll talk behind her so that she doesn't finish. We've still got some working. If you finish your explanation, try to show me another way that maybe you could show this besides the same way you just used. That'd be a neat way to stretch your brain. Do you agree with them? How did you do it?
I did it as a standard algorithm.
The what?
Standard algorithm.
What's that?
It's when you
Well, ask her. What's the standard algorithm?
standard algorithm is when so instead of doing special questions you'd see how many times 32 can go into 48 and 32 can go into 48 one time. Just put the 1 above the 8. And then you bring down the 32, put the 32 under the 48, and that gives you 160. You have to bring down the 0.
I'll let you keep talking. Let me know if you don't get your question answered. All right, so as you're finishing up, if you solved it one way, try to think of another way that maybe you can show me. Provide evidence that it's the same.
Is that easy? Yeah. But this is
Oh, and what was your name? What's that? What's that? One more time? Charlize. Do you mind if I share? Will you mind sharing how you did your answer? Or I'll call you up to the front. Does that sound okay to share with the class? Awesome. Thank you, Charlene. All right, about 10 more seconds. Charlize, Charlene. Charlene, Charlize. Take your thing. Some different ways, if I could get your attention up here. Curious if you guys were approaching it the same way. So Charlize, I'm getting it right. All right. Here's what Charlize did. Take a second and examine what she did. Talk to your shoulder partners. What did she do? Algorithm. We'll get there. It's a good job. Is that what you were doing?
No, I got it different. I did it a different way.
How were you doing it?
Well, first I multiplied 32 times 10 gives 20, then I got 160. Then I multiplied 32 times 5 and got 160. And then I subtracted 160.
And what's your name again?
Isaiah.
Isaiah, do you mind if I call you up to share?
Yeah.
All right, cool. Thank you. All right, who would like to share? What did she do? Who can make sense of her thinking? What do you think?
She did partial quotients. So she multiplied the divisor by a number, and then subtracted that from the number from the dividend, and then wrote down the number that they multiplied, and then repeatedly did that until they got their quotient.
Who can restate? Who can restate that? What did she do? What did she do?
So she saw what 32, how many times 32 could go into 480. So she multiplied 32 times 10, which equals 320. So she subtracted that. She got 160. She subtracted that. She got 128. Then she subtracted that, got 96. Because she had to take out the 1 because she had to, because 2 can't fit into 3, so she had to put the 1 by the 2, so that equals 12. And that's how she got the 9. And she got 96 minus 32, because you have to start doing it by 32 times 1 now.
Mm-hmm.
And then she got
I don't see a 96 is here.
96 right there.
But she subtracted 32, but here I see a 96. Can I share yours?
Yeah.
I see the same answers, but I got different results here. So we got to 96. It looks like it was the same up till then. What's the difference between that way and this way? Talk with the groups around you. What's the difference? Bringing it back about 3, 2, 1. All right, so I see two different methods here. Or it looks differently, but they got the same answer. So what's the difference then? What do you think?
Aiden took the long way by kept on doing 1, and Charlize did 2 and 3, so that's the main difference.
What do you mean she did the long way?
She did the long way because she kept on doing 1, 1, 1, when she could have just done like 5 or like Charlize did 3 and 2.
What does she mean she could have done 1 or 5 when Charlize did 3? What does she mean by that?
Charlize did it the shorter way, and Aiden did it the longer way.
But why is it shorter?
Because the kids did a different. She did a different. A smaller equation.
Smaller equation. What does she mean the smaller equation?
Cadence took the long way by doing 32 times 10, and then repeatedly doing 32 times 1, unlike Charlie's how she put bigger numbers to multiply by.
So why would you want to use bigger numbers, or why would you want to do it by 1? You did it, so tell us. Why?
So then you don't have to keep on doing it by 1, and it would like take up the whole page and have to do another page, and you'll be there till like next year doing times 1 times 1.
Did you feel like this took you a little bit of time?
A little bit.
So how could you have changed this?
I could have done it by 5s or by 2 or by 3.
So like a bigger factor I could have used of it. Okay, excellent job. Thank you for sharing these two methods. I have another way I want to show you. I've seen this done before. What did this person do? What did this person do? Take a second. Hands down, hands down, hands down. Take a second, take a look at this, examine their work and the steps that they did. Thank you. Thank you. Talk with those around you. What did they do? The break apart method? What's that?
Well, I do it for multiple division, but it looks similar. Say, like, smaller or you can just do that minus 60, which is under 60 something that you would then you would, I guess in that case, divide 4 to 3, and then 3 to 8, 2 to 4, and then 2 to 8.
Is that what it's doing? Think on that, okay? All right, bring it back together. What did this person do? What did this person do?
They did the box method.
What's the box method?
The box method is
Want to call for assistance, or do you want to keep thinking on it? All right, who? Calling somebody here.
okay. First of all, he didn't do the box method for his problem. He just checked his work with the box method. Because you see on the side, he actually did the work, and then he checked it with the box method. And the box method is when you put like your main number plus the
your other number on top that that you have to divide the number by. So that's box method the problem.
So what's the box method? What's the box method?
Using boxes to check your work.
Using boxes to check your work. So what if I told you this person didn't check their work with that method? That's how they did this problem. Take a second and look at this. How could they have done their work with this method? Talking to groups, how could they have done it with this? What do you think?
He did his work with the box method.
Think about how you keep calling it the box method. Think about how that works. So that's the connection I want you to think on. And if you want to talk with your group mates, you want to ask them? Because they might know too. What was your name again? Danny. Did they already say it? Did you agree with what they said?
It's also called the break apart method.
No? The break apart method?
Yeah, the break apart. It's like breaking apart a number, then like dividing or multiplying or doing whatever you have to, then putting it back together and then getting the whatever it is.
I've heard break apart. I've heard box. I have something I need to clear up. If I could bring you guys back together real quick. I've heard a few things, and I've heard this before too. I've heard it's a box method, and I've heard a break apart. I've heard this also as the window method. I've heard all of these different names for it. So I have a question for you. Have you seen something like this before?
Yes.
Who can tell me where they've seen it before? Where did you see it before? What do you mean last year? When? So you remember it from last year. Who can add on a little bit more specifics on when they remember it from last year?
We did it last year in 4th grade.
And then what did you do it with in 4th grade?
We used it with addition, subtraction, multiplication, and division.
All 4 operations? Do you agree? Disagree?
Agreed.
She agrees. Okay. Disagree? Maybe?
Last year in the Stolz class, we just use it for multiplication.
Okay. Add on to that?
So in Sammy's class, we I think only did multiplication with it, like 2 by 2 multiplication or 2 by 3 multiplication. And then at the end, we added them up. But this is what we were doing here. But we just are subtracting to get the function.
Interesting. So thank you for sharing. So you guys have done this in 4th grade with addition and subtraction. Do you remember doing this in 3rd grade at all?
Sometimes. Yes. Sometimes.
Maybe?
Yeah. Like a little bit at the end of the year, they started introducing this to us.
So I heard like multiplication, division, where those come in. So in 3rd grade, you've used this before. Like if I was doing 12 divided by 2, I know that my total area would have to be 12. 6. 12 divided by 2 was 6, but also 6 times 2 is 12. So a relationship between multiplication and division. And then last year, you may have done it. So if I was doing maybe, that's a little too big. So if I was doing something like that, same relationship, the connection from third grade, then fourth grade, but here it is again in fifth grade. So let's bring all those definitions back under one thing, because I get confused when I have all these different ways. I heard a box method, I heard the window method, I've heard break apart. In third grade, this was called the area model, because it's the area of the shape. Here it is the area model. It's the exact same model. Here it is, area model. So let's take it from box method, a little informal, take it more formal. It's called the area model. It's the same strategy. So what did this person do? How did they use the area model to solve? What do you think?
So what they did was they did 32 times 10, which equals 320. And so they did 480 minus 320, which they got 160. And then they did 32 times 5 is 160. And then they subtracted 160 from 160, which got them 0.
Agree? Disagree? I see some agrees. Maybe some I'm not sure. So let's restate that. Who can restate what she said? Who'd like to restate it? Okay. Who'd like to restate it? Go ahead.
So what they did, they kind of added partial coefficients with it. They did 32 times 10, which equals 320. So they put that 320 in the main box, and then they put the 10 over it, and then they added the addition sign, and then they did 32 times 5, which is how they got their 5, and then they put the 160 on the side box. And then they probably added 320 plus 160, which equals 480, and what they did on the side there is 480 minus 320.
Which was here. Okay.
And then they did, so since A equals 160, they used that 160 that they did 32 times 5 and subtracted it, and then they had 0, and then they added 10 plus 5.
10 and 5. And that's where they found their solution. All right. Why do you think they chose the 10? Talking to groups, why did they choose 10? Do you agree with them? Okay. So you want to finish it?
So they use 10 because all you're doing is just adding that 0. So like there's 32 and 10, you're adding a 0 to get to the 20.
Do you agree? Okay, awesome. All right, so bringing it back together. Why'd they choose those numbers?
Because if they go over 10, they'll go over the number and they can't subtract, and it will be higher than the number they have to subtract from.
Do you agree? Disagree? So the only number I can choose here is 10. Does I disagree?
I was going to add on that they also
Okay. So as I'm looking at this, did they have to use 10?
They could have used 15 and gotten there instantly, but that would have been a little bit too much multiplication, because you would have had to do long multiplication, like then do the addition that's standard algorithm, then subtract that, then add it all up. It would be a longer process if they did 15, but 10 is a friendly number that it would be faster to multiply, because like things with the one in them, like 10, 1,000, 10,000, 100,000, those are really easy to multiply.
A multiple of 10?
I
So do you agree with choosing a multiple of 10?
Yeah.
So why would you want to choose a multiple of 10? Talk to your groups. Why would you want to choose a multiple of 10?
Say you're gonna multiply by 20,000 times.
Have they used the area model for division at all? Have they used the area model for division at all? So that's why I'm going slow. I'm not going to go to 4 digits probably. You're doing pretty good. Talk it through it.
All you do is just add a 0 1 or just add another 0 1.
Like 10 can be multiplied by anything.
I'd like to talk about one of those comments I heard it a few times, was I add the 0 to it. What do you mean you add a 0 to it when I'm multiplying by 10?
When you multiply by 10, you go up a place value, which is adding a 0.
So if I'm doing 32 times 10, I'd add a 0 to what?
Well, 32 times would add
Tough to put into words. That's okay.
really. So if you multiply by 10
Mm-hmm.
on 32, it would be 320.
So that's just like what's here. But I heard that add a 0. So what am I adding a 0 to?
First, you would you multiplying by 10, you would take away the 0 and multiply it by 1. So you're multiplying 1 times 32. You would write 32 down, and then you would put back the 0
Add a 0 to 32?
at the end.
32 plus 0 equals 320.
You would take away the 0 and then you would add it at the end of.
I did add it to the end of the 32. 32 plus 0 is 320. Okay. Agree? Disagree? Talking to groups. What's going on here?
It'll be 32 because anything plus 0 equals the same thing because you have
Place value, which is multiplying it by 10. And then you'll add a 0.
you have to use exponents.
And exponents. I don't see any exponents on there, do you?
Well, you need to add a 1 by 10 so you can actually add the 0.
But I did add a 0.
No, but still you have to add a 1 right by the 10 so you know that you have to add a 0 because that's just exponent.
But where's the 1 coming from? Because you told me to take away the 0 and then put it back. I took it away when we did 32 times 1 and then I put it back.
You don't do other stuff. You just add the 1 because you have to add a 0 at the end.
Why do I have to add a 0?
Because you're doing 32 times 10. So instead of doing 32 times 10, you do 32 times your 10 to the power of 4.
The 10
So-
is basically your exponent.
So am I adding a 0?
Yes, you're adding a 0.
Yes,
But I added a 0. So think about the wording of how you're telling me to do that. You told me to add a 0, and what did I do?
32 times.
I added a 0. How can you phrase it that maybe it would be differently? What do you think? Is that what you're talking about with the friendly numbers, right? So why does the 0 get put in there? 32. So do I just add a 0? Interesting. All right, because you guys are clearing up some misconceptions that I have here. It's right there, the answer.
It's not really adding another 0.
Hold on 1 second, 1 second. Let's bring it back in 3, 2, 1. Awesome.
So, in my demonstration,
I want you to tell me. Use your words.
So it's really multiplying by 10. You're really just multiplying. So you're going to be doing 32 times 10, which 2 times 0 equals 0. 0 times 3 equals 0. You have to put the 0 because a place value under the 0, because nothing you can multiply. And 2 times 1 equals 2, and 1 times 3 equals 3. And you add, and then you get 320.
So you're proving to me using, it looks like the standard algorithm for multiplication. Okay. But this person didn't use the standard algorithm for multiplication. They just said 32 times 10 was 320. So I like how you provided evidence to mathematically prove it. Great job. But how did they do it without knowing it? Because I was told when we look at this, add a 0. I added a 0. That's what I was told. What did I do? Hold on, I asked, what did I do?
You added a 0.
Yes, that's what you told me to do, right?
It was supposed to be.
So I'm really wanting you to be precise with your terminology, with your math terms, because I did what I was told is add a 0. So if that's not what you mean, I need to present it in a different way. Wanna give it a go? All right.
If you do 32 plus 0, it's just going to be 32. You can't add the 0 at the end because it doesn't make sense. It has to be 32 times 10, or it doesn't make sense if you just add it.
So then how did they know it was 320 just by looking at those two numbers?
Because everybody knows that 32 times 10 equals 320.
I can guarantee not everybody knows that.
Not everyone, but most people do.
Most people? What evidence do you have to support that claim? Because math. No, what? So what's happening? Mathematically, what's happening here? Why do I just put a 0 at the end? What do you got?
Because if you're multiplying by 10 and you only multiply by 1 and you don't use 0, you have to put the 0 back at the end since you didn't multiply it.
I keep hearing I didn't use it. What is 32 times 10?
320.
This number represents what? 10. So when I'm doing a multiplication sentence, what does that mean?
I do have the answer to the question.
Okay, and I want it.
It
So
has everything to do with place value.
what do you mean it has everything to do with place value?
So it's going off of place value. It's going from tens to the hundreds, which that's just dropping 0 at the end since it's really hard to explain in words, but
I know, try.
place value, like when it goes up a place value, it's being multiplied by 10, which it's not adding a 0 since it doesn't have anything to do with any other operations except multiplication. So since it's being multiplied by 10, pretty much the 0 at the end is being used to be dropped at the end of 32.
So I heard an interesting point there. Thank you for sharing. And I'm really good with this question stuff, aren't I? I want you to be very precise because I heard adding a 0, but you're telling me it has something to do with place value. So I want hands down for just a minute because my time is just about up. But I hope as we're looking at today, to summarize a bit, we really looked at the area model for division. And you guys are really starting to explore this. Give me a thumbs up if you'd like to find out further why this is happening. Some do, over half, I'll take it. So looking at this, exploring this, we're going to dig a little bit deeper into the understanding because you've been doing this for 3 years. So let's figure out why that works. All right, so what I'd like everyone to do, say go math. Go math. Awesome. Thank you guys.